Okay, today we're doing 1.1 square roots and perfect squares. As you will start off here, you can see that we got a power here. The big number on the bottom is known as the base, and the little number up the top is known as the exponent. So you can say like 4 to the 2 or 4 squared. What that means, it doesn't mean 4 times 2. It means 4 times 4. It's whatever the base is times itself however number of times. So we can see that's 16. Okay, so then we can go the opposite. Just like the opposite of addition, subtraction, the opposite of multiplication, division. You can do the square root of 16. So what times what gives us 16? Well, that's 4. Okay, and these are just examples to show this, right? So -2 in brackets squared. That means -2 times -2, right? And a negative times a negative is a positive. 2 times 2 is 4. 3 to the 3 means 3 times 3 times 3, right? It doesn't mean 3 times 3 here. It's 3, the base, times itself 3 times, which would be 27. Okay, now, what about 5 to the 7? Whoa, look at that. That's a lot of 5s. But what you can do is this, you can grab your calculator. And on your calculator, there's a certain number of buttons. So it's either going to be a little hat here or y to the x or x to the y. You have to look at your calculator to figure out what it is. So you just plug that into your calculator, and then on the screen, you're going to get your 78,125. Okay, flip to the next page. What we're doing here is these are perfect squares. And when I talk about perfect squares, I'm talking about when I take the square root of a number, I end up with a really nice number. No decimals, no fractions. So what I have here is a list of 1 through 20 and all the squares. Now, do you need to memorize this? No. I have printed lists of these, or you could have your own list. And it's just there to help you speed up when you're doing your math. And then you can use your calculator all you want. Okay, so let's look down here. This is just about patterns. So the square root of 9 is 3, which is a perfect one. Now the square root of 90, no, 9.486 dot dot dot, because it goes on forever. That's a non-perfect square. What about 900? Oh, that's 30. That's perfect. What about 9,000? Well, that's 94.86. No, but if you look at the pattern here, it's kind of interesting. 3, 30, next one's going to be 300. So if there's an even number of zeros here, you can do it. Now, what about this one? 9.4, 94.8. So the next one after that for 900,000 would be 948. Right? You can see the pattern. What about if we go the other way? So we start with 9 again, which is 3, but now we're going smaller ones. So 0.948. See, the decimal is going a different direction now. 0.93, sorry, 0.09 is 0.3. Perfect. And then we can just keep going. You can see the pattern. All we're doing is moving the decimal every single time. That's just there so you understand patterns of how math works. Okay, third page. So what we got here is we can do this in decimal. So 0.5 in brackets squared. Really what that means, if you did it the old way, is 0.5 times 0.5. Well, how did you used to do that? Well, you ignore the decimals, do 5 times 5, and then you count, right? So there's one decimal, there's another decimal. So in your final answer, you have to move it twice, and then we get our 0.25, just like that when we take the square root of it. And that works for like 0.36, square root of 1.44. These are perfect squares because you can find them on the table right up there. The only difference is the decimal spot, okay? Let's talk about fractions. Okay, square root of 4 is 2, square root of 9 is 3. Excellent. Now, what if I gave you the square root of 4 over 9? Well, it's really quite easy because it's the square root of 4 on top, which is 2, square root of 9 on the bottom, which is 3. Well, it's not that bad. You can do fractions. 81 over 100. Well, that's 9 over 10 because the square root of 81 is 9, square root of 100 is 10. Square root here of 225 over 144, 15 over 12. Square root of 121 over 16, 11 over 4. So if you know perfect squares, you can really do a lot of math in your head and you don't need to grab your calculator all the time. But what if you want to estimate? Hey, what's the square root of 8? I don't know. I could plug it into the calculator and do that. But what I can look at is benchmarks. I can pick a number that's lower than 8 and a number that's higher than 8. And the numbers I pick are perfect squares, right? I can do the square root of 4, 2, and I can do the square root of 9, which is 3. So somewhere between 4 and 9 is the square root of 8. And is it closer to 4 or closer to 9? Well, it's closer to 9. So our answer has to be closer to 3. So then I pick 2.8. 2.7 will work, 2.9 will work. Doesn't matter. What about 43? Can't do it. If you plug it in the calculator, you can get a decimal. But a benchmark below, square root of 36. Benchmark above, 49. So our answer has to be between 6 and 7. And it's approximately right in the middle. What about fractions? Well, square root of 8 is pretty close to the square root of 9. And the square root of 32 is pretty close to the square root of 36. So I didn't pick benchmarks in this case. I just picked numbers that are pretty close to it just to estimate. Square root of 9 is 3. Square root of 36 is 6. That's approximately a half. It's just estimation is all it is. Okay, so that concludes lesson 1.1.